Okay, today we are going to learn the electricity consumptions forecasting using nonlinear autoregressive with external exogenous input neural network using Matlab. So the outline for today's lesson, including introductions, seconds is a artificial neural network and from Matlab. Okay, the materials and methods, okay, our data structure, methodology, performance, result, and discussions, conclusions. So as we know, time series is a collection of equally spaced temporal data as shown here. This is a monthly number of airline passengers, okay, from year 1949 to, okay, I think the last year, not since there. It should be 1961 because in a 2 years gaps. Okay, artificial neural network ends. Okay, basically you have the minimum, okay, 3 layer. With the first is an input layer, we'll take the input, okay, the data, and then the at least one hidden layer, okay, to process, okay, the input, and then lastly the output layer to give the output data. Okay, basically inputs, okay, layer, you have the input neuron, let's say x, okay, input 1 go into the, okay, with the input x1, x2, x3, xn, and then each input will be multiplied by, okay, the randomly assigned weight 1, weight 2, weight 3 until weight n, okay, and then, okay, the product of the mean each, okay, input with their, okay, weights, okay, in the x1 time w1 plus x2 time w2 plus, okay, plus the, let's say, x3 times w3 until xn times wn, okay, will be sums, okay, sum, and this sum let's call as a nets. Okay, this net will go into the activation functions, okay, to give a, okay, output. So this is a shown scale. We have the, let's say, n input which give, okay, only one output. So, okay, the yi exactly you have the summation of the wi xi, where the I from 1 up to n. Okay, and this summation is called as a net, will go into the activation function. We have the most, okay, common activation function is a logistic sigmoid function. So mean, okay, here, so this y is actually will go in here. So you have 1 over 1 plus exponent negative. Okay, the x is actually, okay, this thing, summation of your wi yi, summation, okay, the x, okay, x is actually summation of wi xi. So we give a, okay, predicted output. Later on, the predicted output will be compared with the, okay, the actual output. Mean we, okay, inputs, okay, actually we have the input and the and what we call the target. Target is a real output. So the predicted output and the target will be compared in terms of the errors, okay, and ends, okay, will try to minimize the errors, okay, by, okay, later we'll go, it will back propagate to adjust the weight so that the errors will be minimized. So this is actually a feed forward, okay, feed forward, okay, neural network means, okay, in one directions. So once they get the errors, we try to minimize the errors by, okay, and we try to minimize the error by adjusting back the weight. Okay, and then, okay, we have our data structures is actually monthly UTHM electricity consumption data from January 2009 to December 2020. Total is 144 data. Okay, what we are going to put in the input, okay, we have 144 data. So the first column we have month 1 until month, okay, 1 month 132. Okay, actually you can put up, okay, 144 later on, okay, copy this column, okay, it will, okay, move up one rows here. So this will M2, M3 until 133. Okay, and then the same data you copy it. So will be 2 row ups. Okay, until we get this structure is actually okay consists of 132 rows time 12 column because monthly data. So our input we have a 12 okay, columns, month 1, month 2, month 3 until month 12. So the output will start from month 13, means we'll use the previous 12 months to get the okay, predicted at the month 13. This is until month 144. Okay, later I'll show you in the Excel how we get okay the inputs. Okay, will be 132 rows times 12 column. The output will be actually you have 144. Okay, is actually month 13 to month 144 is okay 132 rows times 1 columns. Okay, and then we'll put it into the artificial neural network N apps, okay, which is called as a neural net time series from the Matlab ANN 2020B. And we got 3 options there. We choose the first option, which is a nonlinear autoregressive with externals input NARX neural networks. Okay, means here got 3 types. We choose the first one. Okay, so means we input actually the xt also the yt as a inputs, okay, to get the forecasted result. So xt we have actually just now 12 column, yt only 1 columns. So okay, the input and the output will be provided into the hidden layers. Okay, hidden layers, okay, where consists of the weight and the bias. Okay, the summation of the weight multiplied with each input add up with the bias will go into the sigmoid function. Okay, sigmoid functions here, I think you can set okay how many neurons there. Default is a 10 neurons. Okay, and go into the output layer. Okay, output layer, this is I think using this is a linear okay activation function to give the prediction of the yt. So okay, then you need to input a data. The inputs, okay, I call it label it at the load in. The target is a real output. I label it at load out. And then okay, I think the time series will be matrix row. Okay, in the rows, because okay we have 132 rows. Mean the time series format in the rows, and then stay on. We click next. Default scale, the data 132 rows of data will be divided into 70% scale training, 15% validation, 15% of the testing. Okay, you may change the ratios here. This is a default setting. Okay, and then the okay default key hidden neuron is 10. Number of delay is 2. Okay, and then according to Heaton, the number of hidden neurons could be set according to the side of the input and output layer. Okay, the side of the input we have the okay 132 times 12 okay columns. Output layer is actually also mean 12. What now? When we got 12K output there, and then it said it should be 2/3 the side of the input layer plus the side of the output layer. So 2/3 of the side of the input we got 132, the side of the output 12. So using these calculations, okay, we get the hidden neurons that should be set is hundreds. Okay, and then for the training algorithm, default is a Levenberg Marquis. If they have another two, you can just click the drop down menu to see the other two algorithm and what's the difference is written in the MATLAB there. And then just click the train to train the neural networks. Okay, one done. Okay, means the MSE, the R squared will be appear here, and you can plot the error histogram response. Okay, error auto coloration, input error coloration, and then you just click next. you may retrain again if you're not satisfied with the errors obtained. Okay, so you have a performance, training state, error, histogram, regressions, time series response, error, autocoloration, input, okay, error, cross coloration. Okay, okay, all kind of plots that you can plots there. So this is a progress. This is the algorithm chosen. Okay, and with the performance of the above time series method can be measured by mean absolute percentage error, okay, which is the summations of the, okay, yt is a real, okay, real data minus cap yt, this is a forecasted data. So the, okay, numerator is actually the absolute error divided by the yt. Okay, since our real data is non-negative, so you no need to put the magnitude. So okay, so this is actually the relative error when you sum up from t equal to 1 until n's. Okay, divide by n, so you get the average. Okay, then multiply by 100%, we get the mean absolute percentage error. Absolute because of here, percentage is here. Okay, and then this is the results that we have. Okay, the monthly UTHM electricity consumption by, okay, plot it by years. This is by years. Okay, total got 12 years. Okay, this is collection of time series data from year 2009 to 2020, monthly, monthly data. Okay, this is a all kind of graph that can get it from the, okay, Matlabs. Okay, it sees that the training R equal to 1, mean the regression equal to 1, validations, okay, data, this is a test data, this the all data, perfects the regression coefficient should be 1, so mean perfect match between target is a real data, the target real data, the output is a predicted, okay, data y. So if this is a performance of the training, the mean squared errors, okay, you see is decreasing. Okay, and if possible we want, okay, all these three line, this is a train, the green is a validation, okay, the red color is a test. If possible we want all these three line exactly overlaps so that we wouldn't get the overfitting. Okay, but here is only validation and test are almost, okay, same at epo 4. So these are the, okay, I think the time series plots. Okay, these are the error histograms, time series response, and then the error histograms, this the autocolorations. Okay, error autocoloration, okay, is bounded, okay, it's actually bounded from -1 to 1. Okay, these are the actual because, okay, the and using the first 12, I think total should be the first 12 data to predict the month 13. So the blue show the actual, okay, data, the red is the forecasted data. Okay, these are the future forecast year 2021. Okay, of course this year is December 2020, but because, okay, I have only the data up to 2020, so this one shows, okay, you can get the future forecast 1 year ahead. So okay, the conclusion is actually the data is univariate, mean, okay, depend on the month, okay, month, okay, and then we convert it to multivariate data. We use actually 2020 Matlab 2020, okay, and the UTHM electricity consumption from 2009 to 2021 was forecasted. Okay, I use a Liverbird-Marquardt backpropagation training algorithm with 100 hidden neurons and 2 layers were employed. Okay, data was divided to 70%, 15%, and 50%. Okay, for training, validation, and testing. The MAP between actual and predicted value is 4.16%. Okay, these are the references used. Okay, then show you some hands-on. Okay, like this. We have the UTHM monthly electricity consumptions data from January 2009. Our T is a collection of the months in sequence, actual data until year 2010, 144. Later on you copied this data, this data 144 data, Control C, and then paste one row ahead. And then this one, the third row, two row ahead, 3, 4, 5, 6, 7, 8, 9, 10, 11. So make up total, we got the input is 12 column. So you will notice this is a month 1 data, month 2, month 3, month 4, month 5, month 6, 7, 8, 9, 10, 11, 12. This is a here we paste also 1, up here month 13. So this case the output is a blue color, the input is a red color. And then since we paste one row up, one with one legs, so the inputs you see here, because here the last data is month 144. This one no more data. That's why the input will take until month 1 until month 132. 132 times 12 column. And the output is actually output month 13 until month 144. Then you goes to the Matlab, 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 and then make sure my file, where's my file? My file is contained here, so I copy it, and then make sure you change directory to here, change directory to here, and then we have the apps, select the apps, menu, this is we are neural net time series because we got time series data. So you got three type of ends here. I choose the first one. Predicts a series yt given d past value of yt. So mean the historical value of yt also put it as an input. Besides the xt I makes it in these dimensions. My xt is actually also the y. The y is a blue color. Because I got univariate data only. Univariate data is actually one column time 144 data time one column. And then I want to choose this one where I need the xt I make it as a from univariate data, I make it become multivariate, become 132 rows, 132 rows times 12 column. This is my x. The y is my month 13 until month 144. That is my y. You may try others. Let's say if we choose number 2, then your data structure, the given predict series yt given the past value of yt. So mean you may plug in your data. If you choose the second one, plug in the data. Your y is actually consists of, let's say consists of maybe 144 times one column of the historical data. This is based on nonlinear autoregressive. Just inputs 144 historical data. If we choose nonlinear input output predict series yt given the past value of series xt. They said because why I choose this one, they say NARX solution are more accurate than this solution. Only use this solution if pass value of YT will not be overable when deployed. So mean this only put XT. So using this one compare here, NARX is more more accurate. That's why I choose this one. Okay. Okay, and then next. So the input. Okay, I need my input. I need the input. So I'm going to do scale. Okay, select this thing. Okay, 132. Then Control C. Okay, I go to the Matlab scale command window. Okay, load in. Initially, I just type 1. Okay, and then see, I double click the workspace. Okay, the load in the workspace. Okay, here. And then just now I control C to copy my data. 132 rows times 12 column. Then go into your variables. You just control V. Yeah, control V. So this is a variable load ins, and then you can close it. Let's see. So load in now become 132 rows times 12 column, where the data format is double. Okay, and then you do load out. Let's say equal to 1. So equal to 1, the value is 1. Then you double click your load out. Okay, go to the Microsoft Excel, select the blue color of your data. Control C. Okay, Control C. And then here, Control V. So this is my load out. Then you can close it. So you see 132 times 1. Okay, then go back to the NARX apps, which is NTS2. So the input will be the load in, output is the target. Target is the real data, load out. Okay, you see, default is a column and you cannot proceed. So choose the rows. And then you can click next. So input is a load in is 132 times 12 matrix representing dynamic data 132 times step of 12 element. You got 12 like 12 variables there. Target load out is 132, meaning you got the 132 times step of one element. Mean the output is represent as one column. Then click next. Okay, default scale that 132 target time step is divided into 70% of training, 50% of validation, and 50% of testing. Okay, you may vary it here. So I just use the defaults. So training, these are presented to the network during training, and the network is adjusted according to its error. So mean the weight will be adjusted to get the minimum errors. Okay, validation used to measure the network generalization and to hard training when generalization stop improving. Testing, these have no effect on training and so provide an independent measure of network performance during and after training. So this one, training validation, and then this normally we'll look at this testing, testing accuracy. And we click next. So define NARX neural networks. Hidden neurons. I choose 100. 100. According to the calculation just now. Or default, you can choose. Default is 10. So based on this calculation, the input I got. Layers is 132 times 2/3. 2/3 of the side of input, and then plus the side of the output. the number of hidden neurons should be less than twice the size of the input layer. Okay, so okay, 100, okay, is less than 2/3 of the 132 there. Okay, then what's that? This one delays. Okay, I use the default 2 and click next. Okay, then you got 3 algorithm. Liebenberg Marquis, okay, require more memory but less times. Okay, then you can see others. You can read what is that. So I use the default and then just train. Okay, the equal, okay, or 6, stop at equal 6, okay, out of 1,000. The time, this is a time given for the training, the performance. Okay, the gradient, the mu, the validation checks for, and then you want to see, you can plot. So each time we run, okay, you will have different result. Each time we run different result. Yeah. And then just now, where is it? Yeah. Let's see. Okay, this is a training state. And then the error histogram. Okay, regressions. So, okay, in the slide last time I can get training R equal to 1. This one also. So each time we run, because it's a okay, the data is randomly divided into 70% training, 50% validation, and 15% of the testing. So each time we run, you have a different result. Okay. So this is if possible, we want all training, validation, test, and all here are equal to 1. Okay, and then okay, this is a time series response. Here, these are the corresponding errors for each time series data. Okay, mean this is the target is a real data. Okay, target. Okay, because okay, our data divided into training, validation, and test. So okay, the blue dot is actually the training target, okay, and the training output. So this is a plot of the training target, training output, validation target, validation outputs, test target, test output. All these things with their errors, with the errors for each k time steps there. I mean this is the error, you see. Okay, after that, all these things. The correlation between input 1 and error 1, target 1, okay, mean this the correlation. This is a zero correlation. The confidence limits. Okay. So okay, if I'm not satisfied, and here, okay, how to know which one is the best? Okay, it's normally I will look at the, okay, possible we want the testing, okay, accuracy is more, okay, or where is it? I want this one. So once you you're not satisfied, you can actually retrain. Okay, and then you can see, let's say, regressions there. So I see this time even worse, even worse. Then you retrain, okay? Or you may change the algorithm. So the more I train, this one even worse, validation and the test. So sometimes we have to retrain until you got the good one. Or sometimes when you see it's a good, you can save it. You can save it. So still not that good. Okay, so you have to train it several times. Okay, until you get the your satisfied result that you want. Or you can base on the MSE you want to minimize. Let's say you want to minimize, okay, this one, the testing accuracy, because normally training you get quite high accuracy. We want the testing accuracy because testing is independent with the training and the validations here. So but you can see 252380, this is even higher. Can plot to see. Okay, about still test coloration is about 0.7, validation is even poor. Then you can see when they are poor, when you plot this thing, when you plot, okay, their performance, I think this is matching here, but the error scale, cause it means square error 10 power 5 at here, still quite quite big. Then the errors, the MSE is still quite big. Okay, and then once you're satisfied is actually you can just next, okay, to generate the simple script, okay, we'll save a net there. Okay, the output, the error input, you can save. Okay, let's say you satisfied, okay, you get this thing, and then you can save it and you run it. So but to get, okay, the result like what I obtained here, my slide here, this thing, okay, you need to, okay, modify the code that you save here, the code that you save. Let's say, where is it? Here, this part. Let's say you save it. Editors. Let's say you save. Let's say this one. Show shows. Save. Okay, and then when you run, okay, run the code. Exactly given this thing, the same thing, the same thing. So how to get the, how to plot all the graph, how to plot this graph, okay, and the forecasted, okay, graph, you need to manipulate the coding here, the coding. Okay, you see that here how they predict, how they forecast, okay, these are the code. Okay, the training algorithm, train LM, is a Leavenworth Marquis backpropagation. Okay, the input delays 1 to 2, hidden just now I choose 100. And then you see, okay, this is train the network, test the network. Okay, see how they test the network, you get Y is net, they put it X, XI, AI. E is actually the errors. Okay, subtract, okay, T, what is it, T and Y. what's a T? T, what's a T? Okay, the load in become the variable capital X, load out is a capital T, and what's a lowercase t? Yeah. Prepares the net scale. The net scale X mean our load in X will become the, I think, the lowercase x, load out capital T will become the lowercase t. So train, they put up the net, the neural net, okay, the neural network, and the input X are the mean the input X, the T is the target, okay, XI AI. Okay, XI AI. So to test also you see they call back the net, okay, the net, okay, mean the neural net model, okay, save as a net, input the X, XI AI. So you can see, okay, the what's the XI inside there. Okay, XI you see is a 2 by 2, okay, cell, 2 by 2 cell. Okay, the first cell is 12 times 1. 12 times 1, what's that? Okay, 496. Okay, what's that? 496.37. I think should be the first, okay, 12 data, 496.379. Okay, until you can compare. Okay, the XI number cell number 1 is the 12 row. Okay, 12 row. Okay, it's actually, okay, this one. The first 12 month of the data. The first 12 month of the data. Okay, then you can okay, what is this 1.18, okay, 1.8003 times 10 to the power of 3 should be, okay, where's that? Should be this one. Okay, this one mean the, okay, the target, the first data of the target of the month 13 data, the month 13 data. Okay, where's that? And 1573 is here. Mean, okay, the XI, the first cell is the 12th, okay, month of the data. Okay, second row, first column is the month 13 data. Okay, second row, second column is the month 14 data. Okay, and then we open to see this one. Okay, 580.47. Okay, until 1800.3 should be here. So mean the size variable there. Okay, this will be the, okay, first row, first column. This is a first row, second column. This data is a, okay, this data is a second row, first column. This is a second row, second column. Okay, and look back the code. So this is a the, what, let's say XI psi, AI. Then we open the AI to see what is that. AI. Oh, cannot. AI can open. Can I open? Cannot open the AI. Okay. Okay, then we see, okay, the forecasted, I mean the output is actually the Y. Mean input the X, XI, AI, we get the output which is Y. Then we look at what's the Y. Okay, you see Y is 1 times 130. Okay, one row times 130 cell. So this is the, okay, the Y is actually the predicted output. Okay. Okay, so means here 1994. Oh, of course, different because this is a predicted. So you see, okay, it not predict. We input is actually we input our X is 100 132 times 12 column times 12 column. Okay, and then the target that we input is actually 132 times one column. Okay, but the predicted is actually predicted you have 130 cells. Okay, so mean because these two month 13 month 14 is used, okay, in the size there, in the size variable, in this variable already. Yeah, this is a month 13 month 14. So mean, okay, actually the neural, okay, the n in Matlab use not only 12, okay, not only the previous 12 month of data, but it use up to 14 data to predict only the remaining is start from month 15 until month 144. That's why the, okay, the mean the see, this one can close. See why, okay, the, okay, dimension is 1 times 130. They put chain into row. Okay, so now using this thing we are going to, okay, because if you directly using here, what you obtain is actually the y give is actually from month 15 to month, okay, month 144. Okay, I want to predict 12 more month ahead. Okay, I want 12 more month ahead. So here, is it 12 more month ahead? Let's see. Oh, this one extra. Okay, I want 12 more month ahead. So 2, 4, 6, 8, 10, 12. I want 12 more month ahead. So mean until, okay, month 156, 156. So the coding that I have, okay, chain is actually the end forecast here for the forecasting. What I'm going to do, okay, I will create x, the psi number 1 equal to psi. Okay, and then I'm going to chain, okay, the first, okay, the psi 1, first row, first column is the load in 131. Okay, 131 means start from, okay, 131 column, this thing. Okay, 131, 132. Okay, okay, the load in we have actually 132, 132 times 12. Okay, so mean first row, first cell, first row I will take this one, this 131. Okay, like Matlab take is actually here. Mean this is a okay, or actually Matlab take something like that. Same thing. Is either, okay, the initially psi it take, okay, like this, or it take like this one, is the same thing. They are, okay, symmetrics. Mean this and this data actually symmetrics, right? Mean, okay, psi, okay, the initially, okay, Matlab take the psi, okay, refer one more time, the psi, okay, you open here, compare with the here, mean 496.37 psi 11, here, this data. Okay, first column of the first row are the same. Okay, this is a psi 1, you see the psi 1 until, okay, 1404, and then the psi 1 first row second column is actually 508.4709. Okay, mean it's the second column, okay, second column, or this one, the same thing. I put it to others colors, same. So mean it's actually side, okay, first row, first column, take the first row of data of your input. Side, okay, first row, second column, take the second row of data. Okay, and then side, okay, second row, first column, take this one. Side, okay, and then second column, second row, take this data. Take this one. So this is a, okay, side, first row, first column. This is a second row, first column. Okay, second row here is a side, first row, second column. This is second row, second column. So mean using these two, okay, and the ends predict start from month 15 to month 144. Month 144. Okay, so similarly, I'm going to now using the last two row of the input. Okay, row 131. Okay, my load in as a side 1 first row first column. Side 1 first row first column here. So I close this thing. You see my side 1. The load in because unless I run this thing okay, side 1 is actually I take it equal to load in row 131 comma column, so mean take out all the load in from row 131, put it into the side 1 first row first column. Side 1 first row second column, take the load in 132. Okay, 132. And then this is a load out 143, load out 144. Okay, so you see how I'm side 21. Okay, will be the y. Okay, y is a predicted, so I not use a load out, but I use a y. Okay, in the last two predicted, okay, value y, you have until 130. Okay, total is a 130. Okay, I don't use the, okay, the real data, but I use a predicted y. So okay, total is 130. So okay, first row second row first column, I will take the y129 data. Okay, because it's the y, okay, data structure is first row times 130 cell. So mean first row, okay, the second last data, and then side, okay, 1 second row second column, okay, take the y first, okay, first row of the y, the last data. Okay, and then I will predict y1 using the okay, same command here, the same command just now, the test where is it, the same command here, net, okay, x. So side I change to side 1 with the new input, the new input here. Then I predict, okay, y1. Okay, y1, okay, me using the last two forecasted result, we forecast another 130 outputs. Okay, similar y, okay, and y1, yeah, similar. And then what I'm going to do, so I get y1 is another 130, but I just need actually, okay, I just need mean the y1, I need the first 12 to get this one 2021, okay, forecast result. Okay, so my capital Y is a y initially 130, okay, and then y1 I take the first 12, so total is 142. So it's actually start from month 15. Okay, month 15 mean the forecasted will be start from month 15, until, okay, month 156, because I just take up the new forecasted result. I take the first 12 data only, the first 12 data. Okay, and then so the y, capital Y is what I have. So now we can calculate all the absolute error, mean, absolute error, relative error, absolute error, MAPE. Your absolute errors, okay, we have the, okay, absolute value of the load out, okay, because the y is actually start from, okay, y that MATLAB give is actually start from this one, this thing y, okay, y1 is start from here. This is the y2. So okay, I will have why I put load out start from the third row because here, okay, load out this first row, second row is used in xi side there. So we can calculate the error start from the load out from number 3. Load out number 3 until the row 132. So minus with yy, okay, okay, total y1 to 130. Okay, cos y dimension is 142 times 1. Okay, y the last 12 is a future forecast. We don't have the real data. That's why we can only calculate the error for y is from 1 to 130. Okay, this thing to change, I think, the format of the y. So with the absolute error, you got, okay, total 130 absolute errors. Then we can find the mean of the absolute error. We get the MAE. Okay, and then after that, okay, you can calculate the relative errors, okay, by divide the real data, and then you get the when you get the mean, when you calculate the mean of the relative error times 100%, you get the MAPE. Okay, and then we can plot, okay, the T actual is from 1 to 132, the T forecast is from 15, start from 15, 13, 14, 15, 15 to 156. So 15 to 156. So the actual is actually my load in from 1 to 132. Okay. And then you just plot the T actual with the actual. So this is a real data. Show it in the blue color. Blue color. Okay. And then the for T forecast is start from 15 to 156. Okay. The forecast output is a YY. So red color. And then change the line with. So that's what we get. Okay, that's what we get, this thing. Okay, because the code we save our data, and the net also very safe in the, okay, this data file, so I can just load back to run it. So of course each time we run we have a slightly different result. Yeah. So this is a actual, this is a forecasted, this is a 2021. Because each time we run we have a, okay, slightly different result. So you can see compare with the, okay, because each time we run the data is randomly assigned to 70% training and, okay, 15% validation and 15% of the testing. That's why each time you run you have different result there. Okay, then this one compare to here. So this time out there. Okay, so with this, okay, thank you for your attention. Okay.